Hey everyone, and welcome to this explainer. Today, we're going to completely demystify the algorithms that quietly but heavily shape almost every single aspect of our daily digital lives. I mean, have you ever felt like your favorite apps are literally reading your mind? You know the feeling. You add just one item to your cart, and suddenly the exact accessory you didn't even realize you needed is staring right back at you? Well, today we are going to look under the hood and discover exactly how that happens. Okay, let's dive right into this. How do tech giants like Amazon and Netflix know exactly what you want, sometimes even before you do? It honestly feels like some sort of mind-reading magic, but I promise you it's not. It's actually powered by a brilliant data mining technique known as association rule mining. Instead of just guessing what you might want, they are analyzing millions of past actions to predict your very next move with sheer mathematical precision.
So, what exactly is association rule mining? At its core, it's a technique used to discover hidden relationships and patterns among items buried deep inside massive datasets. The basic format is super simple. If A, then B. In data science, we call A the antecedent, that's the if part, and B is the consequent, or the then part. Think of a classic everyday supermarket example. If a customer buys bread, then they buy butter. The rule simply states that customers who buy bread are highly likely to also grab some butter before they hit the checkout.
Now, take that foundational logic and apply it to a phrase you have absolutely seen before. Customers who bought laptops also bought a mouse and keyboard, right? This is association rule mining in action in your everyday life. Amazon uses these rules directly for their cross-selling strategies. They aren't just putting a mouse next to a laptop by accident. They're doing it because the underlying data rule has proven, beyond a doubt, that this specific combination drives massive additional revenue. And this brilliantly illustrates exactly where those rules come from. Let's ground this concept by looking at a raw 5-transaction market basket database, just like the ones real supermarkets analyze all the time. In transaction 1, someone bought bread and milk. In transaction 2, it was bread, diaper, beer, and eggs, and so on down to transaction 5. Our task as data miners is to sift through this raw list and figure out which items actually occur together frequently, which product combinations are truly common, and which ones are just random flukes.
Section 1. Decoding the metrics, support, and confidence.
To separate those valuable patterns from just random noise, we rely on two foundational metrics. Let's compare support and confidence. Support measures how frequently an item set appears in the entire dataset. Think of it like asking, how popular is this specific combo meal across the whole town? Confidence, on the other hand, measures how often item B appears only when item A appears. It's conditional certainty. Imagine a friend orders a burger. Confidence asks, given that they already ordered a burger, how sure are you they'll also order fries? So, support is overall popularity, while confidence is conditional predictability.
Let's apply this to our supermarket table to find the support for the rule, if bread, then milk. If you recall our 5 transactions, bread and milk appear together in transaction 1, transaction 4, and transaction 5. That's 3 out of 5 total transactions. Divide 3 by 5 and you get 0.6, so our support is a solid 60%. This tells us that 60% of all shopping trips in our little database contain both bread and milk. It's a very popular combo meal for our town. Now let's find the confidence for that exact same rule. If bread, then milk. Here, we have to change our denominator. We only care about the people who bought bread. Looking at our data, bread was bought in 4 transactions total. Out of those 4 people who bought bread, 3 of them also bought milk. 3 divided by 4 gives us 0.75. So our confidence is 75%. That means we are 75% sure that if a customer puts bread in their basket, they're going to add milk too.
Section 2. Lift. The cross-selling multiplier.
So, we have popularity and we have predictability. But to really maximize revenue, we introduce lift, which measures how strong the relationship actually is. Basically, does buying bread truly increase the chance of buying milk, or do people just buy a lot of milk anyway? To find out, we divide our confidence in the rule by the overall support of the consequent, which is milk. Milk appeared in 4 out of 5 total transactions, so its support is 0.8. We take our confidence from earlier, which was 0.75, and divide it by 0.8. That gives us a lift of exactly 0.9375, and this specific number brings us to an absolutely crucial business decision. So the crucial point is how we interpret that lift value in the real world. If lift is greater than 1, you have a strong positive relationship, bundle those items immediately. If it equals 1, the items are completely independent. But if lift is less than 1, like our 0.9375, you have a weak relationship. What this tells a store manager is that bread and milk aren't actually strongly dependent. People buy them together simply because they're both highly popular everyday items, not because one drives the sale of the other. Offering a bundle deal or spending marketing budget to pair bread and milk together here would literally be a waste of money.
Section 3. The Apriori Algorithm Explained.
Figuring out these metrics for 5 transactions is easy, but how do tech giants scale this across millions of items without melting down their servers? Well, the secret sauce is the a priori principle, which states, if an item set is frequent, then all of its subsets must also be frequent. For example, if we know that the combination of bread, milk, and butter is bought frequently, then the smaller combination of just bread and milk must also be bought frequently. This is a brilliant, smart, algorithmic shortcut. It means the computer doesn't have to calculate every single possible combination of millions of items. If a small combination isn't popular, the algorithm immediately knows that any larger combination containing it won't be popular either, saving massive amounts of computing power.
Let's look at the procedural steps to see exactly how this filters out the noise. Step 1 is to simply count single items. The algorithm looks at our database and says, eggs only showed up in one transaction. The support is too low. Boom. Eggs are instantly removed from all future calculations. Step 2 is to generate pairs, but only using the surviving items. So it creates pairs like bread and milk or diapers and beer. It keeps building up to larger and larger groups, filtering out the weak links at every single step until only the most frequent profitable item sets remain.
Section 4. Modern AI and data mining.
Zooming out here, like any technology, association rule mining comes with significant trade-offs. On the plus side, it's the absolute backbone of e-commerce AI recommendation systems and even healthcare analytics, finding hidden patterns that a human eye would never catch, ultimately improving sales and even medical diagnosis. But on the downside, even with shortcuts like a priori, it's incredibly computationally expensive for massive databases. Furthermore, if data scientists don't select careful mathematical thresholds, the algorithm can generate thousands of meaningless rules. A computer might tell you that people who buy toilet paper also buy breathing air. I mean, it's technically true, but completely useless for a business strategy. Which leaves us with this final thought. These mathematical rules are constantly running in the background of your favorite websites, analyzing your clicks, your cards, and your views in real time. They know the support, confidence, and lift of your behavior. So if algorithms know our habits this incredibly well and know exactly what to put in front of our eyes at the exact right moment, who is really making your next purchase? You or the math? Thank you so much for joining me for this explainer, and definitely keep your eyes open the next time you shop online.